Okay students, so today we will be starting a new chapter called the arithmetic progression, okay, or in short we can call it as AP. Okay, now what is this chapter? It is actually a very interesting chapter. Arithmetic progression, any kind of progression means a series. Okay, a progression always means a series. Now arithmetic progression is a particular type of series. Let me take one example. Very simple example is 1 2 3 4 5 6 7 8 dot up to 99 comma 100. Suppose it stops at 100. For example, just let's take an example. Suppose it stops at 100. Now this I can call it as AP. This series or this progression I can call it as AP. But what is the reason actually? The reason is the terms. Okay, the reason is actually the terms. Now if I don't do like this, if I subtract any two terms, suppose 2 minus 1, what will 2 minus 1 give me? 2 minus 1 will give me 1. Now I subtract these two, 3 minus 2, any two consecutive terms. I am not taking any random terms. Suppose 1 and 8, I am not taking like that. I am taking only consecutive terms, that are those terms that are side by side. It is 1 and 2, 2 and 3. See, 1 and 2 are side by side, 2 and 3 are side by side, 3 and 4 are side by side. Now this is also 1, 3 minus 2 is also 1. Now I do 3 minus 2, then 4 minus 3, 4 minus 3. This also gives us 1. Now 5 minus 4, 5 minus 4. This also gives us 1. Now 6 minus 5. This also gives us 1. You can do it hundreds of times for the whole series. Now I am just showing you for the last two terms also. 100 minus 99. Again it comes 1. See, notice all the difference between the consecutive terms, it's coming as only 1. Okay, the difference between consecutive terms is coming as 1. This property is known as AP. What is the property of AP? That there is a common difference between all the consecutive terms. There is a common difference called as D, small d, common difference between every consecutive terms. Now if you ask me what is terms, terms are each of the elements of this series. There's 1 2 3 4 5. These are all called terms. Okay, 1 is a term, 2 is a term, 3 is a term, 4 is a term, 5 is a term. Every one is a term. Okay, every element of the series is a term. So this is a property that is to be maintained for an AP series. Okay, AP series works with this property. There is a common difference called as D, small d, between every consecutive terms. Okay, 2 minus 1, see it's coming 1, 3 minus 2 it's coming 1, 4 minus 3 it's coming 1. Okay, that's why it is a AP series. Now if I take a random series, suppose 1 3 9 11 13 45 64, see, is there any common difference? Now 3 minus 1, what it gives you? 2. Now again do 9 minus 3, what it gives you? 6. Now again do 11 minus 9, what it gives you? 2. Now again you do 13 minus 11, again it gives you 2. Now again do 45 minus 13, it gives you what? 12. See, there is sorry, not 12, 32, no, not 30, yes, 32. Okay, 32. See, is there any common difference? Here the difference is coming 2, here the difference is coming 6, again 2, then again 32, then again something else. This is not an AP. We can't call this an AP. Okay, because the difference is not common. The difference between consecutive terms is not common. That means we don't have a common difference. That means it's not an AP, because it's not obeying the principle of an AP. Okay, so the principle of AP is actually that there must be a common difference between the consecutive terms, between all the consecutive terms of the series. There may be finite series or maybe infinite series. So AP can, number one, AP can be finite. Okay, number two, AP can be infinite. Okay, AP can be infinite. Finite AP, infinite AP. Now see, this is a finite AP because the AP is stopping at 100. Now if I just gave over here from comma, then dot up to, I give this sign infinity. Now it will continue to infinity. That means it won't stop, never ever. It will not stop ever. Okay, so actually this is the main concept of AP. Now I will show you the general form of an AP, how an AP is actually, how a AP series can be generalized. Okay. Okay, now let's continue with the common difference that I said, the general form of an AP. A general AP looks like this. Okay, a general AP looks like this, like A1, A2, A3, A4, A5, A6. dot 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 up to an. Okay, that means there are n terms. That means there are n terms. There are n terms. Okay, because it's continuing up to an. That means there are n terms in this series. So there are n terms in the series because the last term is called the an. Okay, the last term is an. The first term is a actually. Okay, the first term is a, last term is an. Now I said common difference. Let common difference be d. I have taken the common difference as d. So now the first common difference will be a2 minus a1. That will be equal to d. Next a3 minus a2. That will be equal to d. Now a4 minus a3. See, difference between all consecutive terms. That means the second term minus the first term. Okay, right minus left, right minus left. That means right term minus left term will be equal to d. Now a5 minus a4 will be equal to d. Sorry, will be equal to d. Okay, dot 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 up to, if you go up to like this, see, I am just doing one modification, small modification is there. Before the nth term there will be a n minus 1 term. Okay, there will be a n minus 1 term. Okay, first it will come as a5 a6 dot 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 an minus 1 comma then an. Okay, first come an minus 1, then comes an. Okay, now if I also do the difference between the two terms, that means a of n minus a of n minus a of n minus 1, that will also be equal to d. See, all the common differences you can see, they are d. See, they are d. That's why I can write it in a special form. That special form, see, it is like that. Therefore an AP series can be denoted by this: a2 minus a1. See, all are d, so I can write a2 minus a1 equal to a3 minus a2. That will be a2 minus a1 equal to a3 minus a2, because that is also d. Next, that will be equal to a4 minus a3 equal to a4 minus a3. Okay, now it can be continued dot 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 up to equal to an minus an minus 1. Okay, and that thing will be equal to d. So this is the general representation of any AP series. Okay, this is a general representation of any kind of AP series. So a2 minus a1 will be equal to a3 minus a2. Why? Because this is also d, this is also d. Now this is also d, this is also d. So a4 minus a3. Now I have written dot 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 because I can't write all the terms, because n, I don't know the value of n. N can be 1 lakh, 1 crore, 1 million, 1 trillion, anything can be n. Okay, I don't know all the terms, so that's why I have given dot dot dot. Okay, but the last term I know, that is, it will be an, and an minus, that means last term minus second last term, that will also give you the result d. That will also give you the result d. So all of them will give the result d. Okay, understood this thing? Next, what are the possible values of d in an AP series? Now d can be greater than 0. Number 1, d can be greater than 0. Number 2, d can be less than 0. Okay, d greater than 0, d less than 0. Okay, and number 3, that d can be equal to 0. Okay, these are the 3 possible values for d. Okay, d can be greater than 0, d can be lesser than 0, and d can be equal to 0. Okay, now I will give you an example. See, the previous example that I have taken, 1 2 3 4 5 6 7 8 up to 100, that was a d greater than 0 example. Okay, the d was 1 actually, so 1 is always greater than 0. Okay, that was a d greater than 0 example. I will take a d less than 0 example also. Okay, now let's take this series as an example, as a d less than 0. This case, see, now you can see this is a series that contains negative numbers, the same series that I have taken the first time, but all they are negative numbers. Okay, now let's find out d. So what will be d? Consecutive difference between consecutive terms. So minus 1 minus 0, it will give you minus 1. Next comes minus 2 minus of minus 1, that will come minus 2 plus 1, that will be equal to minus 1. Then comes minus 3 minus of minus 2. See, right minus left, I am doing right minus left. See, right minus left, that will be equal to minus 3, minus minus will be plus 2, and it will become minus 1. See, over here also comes minus 1, here also comes minus 1, here also comes minus 1. Now if I do minus 4 minus of minus 3, then also minus 4 plus 3 equal to minus 1, here also comes minus 1. So all they are coming minus 1. Now I can write just dot dot dot, and the last term, that is minus 100 minus of minus 99. So that will also give you minus 100 plus 99, that will also give you minus 1. So over here the common difference is actually minus 1. So this is an example of where d is less than 0. Okay, this is an example of where d is actually less than 0. Okay, now d equal to 0. Now the d equal to 0 term is a very what should I say, is a very simple series. Okay, I'm just rubbing this portion, I'm just showing the small example. D equal to 0, the example will be now d equal to 0. Now d equal to 0 is like that, 2 2 2 2 2 2 2 dot 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 up to 2. Okay, nth term, up to nth term, nth term. Okay, now see, if you subtract any consecutive terms, 2 minus 2, it will become 0. Now again 2 minus 2, it will become 0. Okay, so here is an example of d equal to 0. Okay, see, d equal to 0. This is an example of d equal to 0 where all the terms are actually same, they are all identical to each other. This is an example of d equal to 0. Okay, now previously I have also shown you this series, that is a1, a2, a3, a4, a5 dot 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 up to nth term, that is an. That is, it will, the second last term will be an minus 1, the last term will be an. Okay, now I have taken common difference as d, same. Now what I said, a2 minus a1 equal to d, a3 minus a2 equal to d, that means right minus left. Each consecutive term, that is right minus left, right minus left, right minus left, right minus left. So every difference between every consecutive term, that is every difference between right term minus left term, will give you d, that is the common difference d. Okay, so a3 minus a2 will also be equal to d, a4 minus a3 equal to d, an minus 1 will be equal to d. Okay, now what I will do is, over here in all the 1 2 3 4 equations, I will take the a1 to the right hand side. Okay, a1 to the right hand side, so it will be looking like this, a2 equal to a1 plus d. See, it's that the minus a1 will go to that side, will become plus a1. Now a3 equal to a2 plus d. Okay, now a2 has its own value, see, a1 plus d. Now put this value, so a2 has its own value, see, a2 has its own value, so I will put a1 plus d over here, a1 plus d plus d, so it will become a1 plus 2d. Okay, now next term is a4 minus a3 equal to d. Now a4 equal to, now I am taking the 3 to that side, so a3 plus d, because minus a3 will go to that side, become plus a3. Now plus a3 has its own value, see, this is the value of plus a3, a1 plus 2d, put it, a1 plus 2d plus d, so it will become a1 plus 3d. Okay, a1 plus 3d. Now this will go on, now this thing will go on up to how much you want, this thing will go on. So as a general, I can generalize the series as a1 is the first term, the next term will be a2, that is I can represent in form of a1 plus d. Okay, the next term will be c, a3, that means a1 plus 2d. The next term will be a1 plus c, 3d. The next term will be a1 plus 4d, isn't it? Understood how this series is looking, comma dot 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 dot, this will be looking like that. Now as you can see, when every term goes on, one difference is getting added, as you can see it. Okay, see, the a1 was first alone, the a1 is actually the first term of the series, that is represented by a1. Someone can also represent by a also. Okay, just a single a, no need of one. Okay, so a1 is the first term of the series, second term will be a1 added with the difference. Okay, now third term will be the second term plus the difference. See, just one difference is getting added, as you can see over here it's plus d and here is plus 2d, that means one d has been added, that means one difference has been added. Now this one is again one difference has been added to its previous term. Over here again see one difference has been added to its previous term. Now this I can call it as AP, because in AP actually the next term will be actually difference plus the previous term. The next term is actually difference plus the previous, see, difference plus previous term. Over here also see the next term, that means this term will be actually difference that's d common difference d plus previous term, see this one. So see over here a1 plus d, it will be a1 plus 2d. See, that means if you go on to the series on the right hand side, that means if you will go on with the series, what you are actually doing is you are adding d to every step, you are adding d to every term and getting the next term. What are you seeing? You are adding the difference to every term to get the next term. Okay, that is actually what an AP series is. You add the difference to the previous term to get the next term, again add the difference to that term, get the next term, again add the difference to that term, get the next term. That's how it goes on. Okay, Okay, so now I have taken one example from your book. Okay, not an example, actually sum of an exercise, 2 part 1. Okay, exercise 5.1. This is of exercise 5.1. That is the first exercise of the AP chapter. So over here it's telling first term is A. Actually A is equal to 10. What we know as A is the first term. As we have said that the general AP series looks like A comma A plus D comma, as I have said over here I have written A1 in the previous just few minutes ago, but you can, I have said there also, you can also represent it as A. Okay, because A is the first term. Now next term will be A plus 2D. Okay, now next term will be A plus 3D. Next term will be A plus 4D. As you know, I have shown you this. Okay, now in this sum they have told you to write 4 terms. Okay, they have told you to write 4 terms of the AP. Okay, where A is the first term and D is the common difference. We all know this concept. Okay, now these are the 4 terms. So 1, 2, 3, 4. Excluding A, these are the 4 terms. Okay, now let's write. So A is 10, comma A plus D, that means 10 plus 10, comma A plus 2D, that means 10 plus 2 into 10. Okay, comma A plus 3D, that means 10 plus 3 into 10. Okay, comma 4D, A plus not A, sorry, 10 plus 4 into 10. Okay, like that. See, 4 terms are done. 1, 2, 3, 4. The 4 terms are done. 10 over here it will come as 20. Now it will come as 2 into 10 is 20 plus 10, 30. This will come as 40. That will come as 50. Now this is your series. This is your required series. This is your required series. The 10 is the first term and all those are rest terms, and you can also see that the difference between every consecutive term is actually 10. It's coming perfectly as 10. So that's how you form an AP series. Always remember that the A represents the first term and D represents the common difference, and in some cases you will also find AN. This will represent the last term or the nth term. Okay, suppose n is 1 lakh, so an is the 1 lakh term, that is the term at the position 1 lakh. This will be the an term. Okay, let's take some more examples. Now this is also a sum that is taken from exercise. It is 3-part 3 sum. It looks like the AP series looks like this. Now they have told you to find out the first term and also the common difference. Okay, now all of you can see this is a common sense that the first term, the first element that is occurring where the series actually starting, that will be the first term. So you can write first term, and you all know that I have also told you many times that the first term is represented by only A, that is equal to 1 by 3. So the first term will be actually 1 by 3. The first term is the first element occurring in the series, the first number of the series. Okay, that is the first term. So A equals to 1 by 3. Now what is D? Now as we know, common difference is represented by D, that is equal to subtraction of any 2 terms. You see there are 4 terms given or there will be 100 terms given. What you have to find for the D is just subtract any 2 terms. Any 2 not any 2 terms. Suppose you subtract 13 by 3 and minus 1 by 3. 13 by 3 minus 1 by 3. This won't give you the common difference. Any 2 consecutive terms. Okay, you have to subtract. Let me take suppose this 5 by 3. Let me take the simple one, that is these 2. Okay, the first 2 consecutive terms. Which one from which? Subtraction means something minus something. So which one minus which one? So I will always consider right minus left. Okay, always remember this, right term minus left term. So which, see these 2 are consecutive numbers. I will take the right term first, then the minus the left term. So 5 by 3 minus 1 by 3. So that will be equal to, actually take the LCM. So it will be 5 minus 1, actually 4 by 3. Okay, it's coming actually 4 by 3. So D equal to 4 by 3. See the 2 answers. This is the answer 1. This is the first answer. And this is the second answer. Okay, this is how to do this type of sums. These kinds of sums are all of there in the exercise. It's a very easy exercise. From the next part, that is the nth term or the sum of all terms, those are a little tricky portion, but this is the only basic portion. I hope all of you understand, have understood. We will continue with the next part from the next day. Thank you.